I'm gonna work on the documentation extraction tool today with my magnificent OCaml foo. Hey, great Les. Great. If the music's too loud, just let me know. It's like the first time I'm trying to play royal-free music. Kind of like synthwave, so thought it would be a good idea to take a nice track there. I think it's not your internet. I also have like a huge delay. Oh, my phone boots up. Maybe let's wait a few minutes until I can. Shouldn't take too long, like 5 minutes at least. Probably make a comment here. Bzz. I actually set up my my camera a little bit behind my screen, so hopefully you actually see me a little bit better now. Not sure if people even watch me. But you know. Oh, this is perfect. Holy crap. This is good. This is great. Here we go. Okay. So yeah, my OCaml is quite decent, I would say. But I'm only using OCaml for like internal development. I'm not using it for any like production code bases or whatever. Okay. I need to reorient myself because I have no idea what I'm doing here. So let's create a goals document just to have some structure here. So we want to extract documentation. And for that we need, yeah, like extract documentation from a RESI file. And we already have like a binary for that. So we got a simple binary and we want to export, like we want to parse the documentation headers. And we want to put that in some structure and then output that stuff in JSON for now. Later on, maybe let's try some naive markdown. And one sec. So we extracted documentation and we are, that's it. That's basically it. So what kind of data we want to extract? So first of all, we want to have like types, which includes records and variants and abstract types. And that's it for now. And then we also have values. And for values, we usually do, I don't know, functions, for instance, and plain values. But these are all the same, like everything is kind of a value. And then we have submodules. And the submodules are probably, Also not too hard. Actually, we need to do this kind of recursively. Because a submodule consists of types and values, and you can like extract that as well. And I don't know. I think this was this basically. So we have our doc item thing here. We have like a submodule doc item, and in there we have our like arbitrary structures. We need to put that in some kind of format. And I've been talking to Cristiano about this. Like in the beginning, I wanted to take the parse tree, like the AST elements of OCaml or of Rescript, and augment them with some like data. For instance, like the docstring data or the signature data, whatever. But this turned out to be a little bit more like unnecessary work, because like then you need to represent the whole AST and all its like substructures. And if you look at the AST, it's actually I can show you. This was like the promised thing. I told everyone we are going to look at insane documentation. It's like the Parsetree thing. So when you're parsing some source code into an AST, abstract syntax tree, you usually use the Parsetree module to manipulate that. And this is like super low level. Like this is on the compiler level. And usually it's not recommended to work on that. So if you're like working on an OCaml application, you're probably not going to use these kind of structures, because they're subject of change. So whenever the OCaml team decides to introduce changes to the AST, all the dependent code will break, which is usually not good. And an AST is kind of super low level, and there are abstractions on top of that. So if you're using, like if you want to build some syntax extensions and stuff like that, you usually have like extra libraries to wrap around that. The Rescript project is not too fond of this kind of approach, because we want to have as few abstractions between us and the AST as possible, because otherwise we have like a lot of extra overhead, and we want to be fast. We want to be really, really fast. So we take this toll of being incompatible with the rest of the OCaml ecosystem. So we are always like, we are based on OCaml 4.06, like here. This is this version. So Rescript, the compiler of Rescript, is based on this specific API version. And whenever you want to use OCaml code with Rescript, you need to target this specific version. You cannot just use more modern OCaml stuff. That's probably the biggest limitation, but it's actually not that big of a limitation. So, yeah, so we have like, I try to explain this so people like me later on when I watch my video understand what these things mean, because they are literally like, there's no comment, no comment on what this is. You need to basically read the OCaml source code to understand that. And I guess the OCaml approach would be, or the OCaml explanation would be, read the damn types, they explain themselves, right? And I partly agree. Of course, they kind of explain themselves, but you also need to be a compiler engineer to understand that. It's daunting. Like, it's daunting to look at that. And if people don't understand that this is daunting, then there is a problem. Anyways, so we have extension points. Extension points, let me see if I can showcase some. If you go to the rescriptlang.org website, we have like this nice syntax lookup thing. But I actually didn't document extension points yet, so let's go to the language manual. And we have attributes. There we have an extension point. So an extension point is kind of like a placeholder in your AST. And they don't have any particular meaning unless the compiler treats them particularly. You can give them like an arbitrary name like %raw, and then you can give it some payload or whatever, like a string here or some other kind of data. And this is kind of, that's what I assume an extension point is here. So yeah. So it has like an AST type LOC. The LOC means lines of code or something. LOC or location, sorry. The AST location, and like a specific type, like a phantom type of thing to verify, like to classify this kind of. Let's look what it is. We have LOC. This is like a type parameter, location log, and in there we have like a txt and LOC. And so in our case, like when we go back, now this is where the abstraction begins. So we have like an extension point, and in there we have the AST types.loc with a string. So this will be a node, like this will be a record with a txt of type string. So I guess if I would parse like this, the txt would be probably raw, if I'm not mistaken. And then it also got a payload, and the payload is in between the parentheses here in Rescript Syntax. And then we can see it can either be a structure, a signature, a core type, or a pattern. And wow, this is actually super interesting. This is super interesting because we finally see all these like fundamental parts of the OCaml language. We have structures, we have signatures, right? Structure is usually something you put into an implementation file. So when I'm writing code like this, like I'm in my OCaml file right here. Maybe let's go to some code which makes sense. So let's say I define my function extract file, and I get a file name. Then this is like, and this is like in an ML file. An ML file consists of multiple structure items, right? And then we also have signatures right here. And signature items are the exact same thing like what I described here, but for interface files. And sometimes they are even mixed, I think. So let's make a hypothesis. Oh, I cannot speak. Hypothesis. Hypothesis? Ah, you know what I mean. So if I define like a string and I give it some kind of signature here. So my assumption would be that if I do this, then this would be like a structure item. And in there, we also have like a signature. And we can see if we can verify that claim. So first of all, we would get our signature, no, not signature item, but structure item. And within the structure item, we have a description and a location T. So first of all, the location T will point to the exact very location where this is being parsed. So if this is like on line 322, on 1, 2, 3, 4, 5, like fifth column, this will be in the location data. And within our structure item description, we now have all this stuff we are looking at. So this would be a value, because this is a value, it assigns like a string. And then we need to follow this. This looks super daunting at the beginning, but it's actually super simple. So what they do is they namespace their variants. Like here it's like a Parsetree structure, I think. That would be like the mnemonic. God, English. my English is terrible. It's the Austrian English dialect. Oh, I don't know if you have been in Austria before, but we speak like that. Anyways, we have our P structure value, and in there we have like a recursive flag. So what I can do is I can define let rec stir, some param, and then we call stir param. Oh, and this is terrible because I have no idea of like OCaml syntax is insane to me. I think this is like concat. Hello? I'm not even sure if this compiles. Let's see. So we... yeah, Arnold Schwarzenegger is hilarious. He's from Styria. And the Styrian people, they have... They sound, like when they speak, they sound like they have something in their mouth all the time. Like we would say die bellen. And bellen is like the German word for bark, like when a dog barks. So Arnold Schwarzenegger is belling a lot. So yeah, so this is actually compiling. So this would be like a recursive function, a recursive value, which is also a function. And it can call itself with whatever. I mean, this is like a meaningless thing what I do here, but you get the idea. So this is the recursive flag, and then we have a value binding, which is a list of value binding. And in here we have a Parsetree value binding. This is PVB, and we have pattern, expression, attributes, and LUC again. You will see this attributes and LUC a lot. Oh God, this is I love this session. I love this session because like I never went through this whole thing and analyzed it like this. I think this is really, really awesome. This will be super valuable, like if I put this on YouTube or whatever, that people can pick it up and see what's going on. So yeah, so we have like the expression thing and we have the pattern thing. I'm not entirely sure why expression and pattern are in one record here, but we also have attributes. Attributes is actually quite clear. This is also the thing we mostly care about. So an attribute is kind of like a decorator in JavaScript. It's a little bit different. We have different kinds of decorators. So we have one on a module level. If you have like two ads, it's attached to the module. So we're annotating the module itself. And then you also have like simple decorators like this, and those attach to either, I don't know, types or externals, or you can even like create your own one. For us, the most interesting part would be OCaml.doc, for instance. This would be an attribute. And I just made the mistake that this is Rescript. And Rescript has awesome syntax, I understand. In OCaml, it's completely different. I think in OCaml, it's... okay, I need to Google it actually. OCaml decorators. It's not a decorator, it's an attribute, right? OCaml attribute. Okay, now it's getting real. We're going in to the manual. And the manual is using BNF grammar to tell a user how to use an attribute. Fantastic. God, I hate this. Who is reading that? Might as well learn SQL. But this... Okay, where are the examples? Okay, there's one example. We have a module decorated, edit foo, and then yeah, like this. But why do they use... Okay, so they have the module and they attach it with the add to the submodule. But he also, oh no. Okay, I got it. So in Rescript, we simplified the ads. In OCaml, this would be a triple at. That's why they have like triple at somewhere. Trip. Yeah, like this. So this would be on the module level. And then you have at. So they put brackets around it, at, and then they put in the name of the attribute. So we would use at, deprecated, don't use this for God's sake. So if we compile this should work. And if we run it's been about a week on that side when I was modifying reason.vim on my system. Fun times. Yeah. It's a warm hug. You feel instantly welcome. What I try to do here is I try to figure out. Oh yeah. So we have this function here, but I think I did something wrong. How do I attach this to the value? Do I need to? Oh. Am I totally crazy? Oh, I can check the source code of Maxime. Maxime does OCaml properly. Or he doesn't. No! Where is it? There must be some... Oh yeah, here. Here is attaching something. Like you can attach attributes to all kinds of structures. Here it looks like he's attaching it to the function call. No, the OCaml manual is the OCaml manual. It's supposed to be like for everyone, I guess. Everyone uses it as a user manual. You can go to ocaml.org. There is no official. There's no handbook or whatever. Like the most official one is probably Real World OCaml. This one, but this one is basically like Chain Streetwear. I mean, it's also co-authored by Yaron, but this is like the most comprehensible piece of literature. I mean, there are some books, but people want you to also read the OCaml manual. They point to the OCaml manual every time, every damn time. And I got sick that the Reason community does the same thing. Like, okay, you're a JavaScript developer. Hey, let's go to the OCaml manual. Point them to like BNF grammar. But I can see why this is made. Like, if you're a compiler engineer, you mostly care probably about this thing. Like if you work on the syntax or if you work on the type checker. And it's fine. This is like, it's a technical spec and it's super nice. Maxime told us that, yeah, as you said, he's planning to write a spec for Rescript Syntax, but don't expect it to be that soon because, like, we're still not entirely sure how to manage our time for that. Yeah. There will be hopefully a spec at some point, but I cannot promise when. So here he's defining the function write file. Okay, I wanted to go back to actually explain what this all is. So we have these attributes, and these attributes are important because they can attach like arbitrary data to your functions and values. And here we are using reanalyze, which is like a different binary which parses OCaml or Rescript source code and then analyzes the exception handling of your program. And then it will check if your program runs into endless loops, and it will also check if it runs into uncaught exceptions. So whenever I'm using write file and I'm not handling the error, then reanalyze will tell me that. And attributes are used for pretty much everything. We use them for externals to signify certain attributes for the external itself, but we also use it for, I don't know, for documentation extraction. And if you look at our test.resi file, is it called like this? Foo.resi, yeah. So in here we are using also like these attributes, OCaml.doc, and this is one that we need. So what we need to do for our task is we need to traverse the AST for every type, for every value, for every like variant or whatever, and extract all these attributes from there. And these are like the attributes we care about. And in case of a value binding, we have like a pattern and we have an expression. And expression should be clear. So when I'm going back to my program, pretty much everything is an expression. So this would be an expression, and this would be an expression here, and yeah, and then you just need to deconstruct this and get the expression description. And in this case here, it would be what would it be? It would be another value. So you would get another what would it be? What would it be? What would it be? Probably let or no, let, or maybe apply. I don't know. I don't care actually, because I only care about like the top level functions here. Okay, so this is like the basics, basic. There is also like this thing called patterns, and these are probably related to pattern matching itself. So we have a pattern description, and also Bob has been tweeting about it, that we are getting some extension to this pattern matching thing. This all makes sense. Like when you understand the AST, suddenly it's way more clear what Bob is talking about. Like this. So we are working on an extension to make pattern match work on modules. And I guess he was extending the pattern structures in some way, or like kind of handling it probably. Okay, we have any, we have var, we have alias, we have constant, interval, tuple, construct variant. Okay, so maybe let's see how we did it with, let's say, so this is our binary, and we tell the binary to extract a file with a certain file path, file name. And we will check the parsing engine. If it's like an MLI file, we convert, we use the Rescript driver to parse it. And if it's a RESI file, we just use the right configuration in our Rescript driver, like in the syntax. And then we create a parse result. We parse an interface and give it a file name. And then we get out a parse result. And the parse result is, as we said, a parsetree.signature. Oh no, it's a parse, wait. It's a parse result which contains a parsetree signature, I guess. And the parse result has a field parsetree, and in there is the AST thing. We don't get any type completion here. We just get the generic thing. I'm not sure why. But it's a parsetree signature. If we go to extract signature docs, we get in the parsetree signature. Type signature. And in there we have a list of items, like a list of signature items. And now we need to do all this, you know, jazz of fold left, like reduce the list to something. In our case, we want to have items. A list of doc items. You can see it on the bottom right there. Oops. No, you can't. So a doc item list, and then we take these items and stringify them with JSON.stringify pretty, and then we print it to stand it out. And so how do I use this? So if I run the binary and run it on RESI, then I will get a JSON data structure out. And as you can see, this is already really nice. We get basically a tagged union type out of there, like a list of tagged unions. And this is like the intersection value kind, which can be doc type or doc value or doc variant or whatever. And in there we have like our signature. And we're also using, like, we're parsing the signature of, we're parsing the signature of the AST structure. So if I'm having a function, I take apart the function and take its parameters and all its other values in there and pretty print that with our Rescript printer. And if you print it like with the OCaml printer, this would look like an OCaml function, but it's not. It's printed with Rescript, so it looks like a Rescript function, of course. And this is what we have been missing so far. This was like the hardest thing. It's not hard. It's just work that needs to be done. And we also wanted to extract, like we wanted to give or get some name. So we now know this is like a doc value and it has a name add, and then it has a doc string. And we usually just take the doc string verbatim without modifying it. We're not doing anything fancy with that. We just want to take the markdown. Excuse me. So we want to take the markdown and or the plain text within the element. So if we have foo.resi, we just write, I don't know, some example, and it will be taken like this. So we have an example right here. So we have an example here. We write our documentation just like in Markdown, and it would just parse it as that. And in the end, we will just print it out like a typical Markdown thing. Good. So this is what we support right now. We have like an abstract type, and I think we can find this like here. So we have this extract doc function. Within there, we get an accumulator. And I also wanted to rewrite this. So I don't want to use lists for this. I just want to have one mutable array and push everything on that, because list iteration is tedious and I want to shortcut it, and also think that the array access is actually faster. Yeah, anyways, for now, we are taking the signature item, get the description, which is a signature item description, and we pattern match on that. And then we are looking for like things like if this is like a basic attribute and we have like AST text, OCaml text, this means this is like a module-wide documentation string, like this. Don't worry about the attributes because they will be hopefully desugared or sugared by the syntax itself. They will be basically comments. So let's see here. This module is made for for demonstrating our doc extractor functionality. So if we do this, I think that there will nothing will happen if I run this now, because I'm not actually doing anything with this. So I'm using the basic attribute here. I pattern match on that, but oh, it's a doc text actually, but it doesn't show up. So what did I do here? Oh, it's probably at OCaml text. Yeah. So this would be the right representation for a global thing. So now we have doc text. This module is made for extracting functionality. And we also need to get some inspiration from the Rescript compiler itself, because the goal is to be able to extract all the information from belt and etc. So if I go into the JS compiler, others, we'll find like millions, bajillion modules. And these are actually our typical, I don't know, like belt modules, for instance. We have belt, let's say, no string, we don't have string. Belt array 2, no belt array. MLI. And here we can see some, like this is now an OCaml doc string. So OCaml has its own convention for documenting. And it also comes with its own syntax, because this is what every programming language wants to do. We don't want to do that actually, because we think that Markdown, like just plain Markdown, is so much simpler. There are a few things we need to watch out for, like cross-referencing or something. This is not that easy. They do cross-referencing like this. But I think we can get away with some reference And then we can also do like this kind of weird thing here. I don't know. Actually not like this, but I would probably do like hashtag type or value get unsafe, whatever. Because this is like in the same module. So we just like reference to it with anchor refs. And if it's like in a different module, I don't know, string hashtag value minus get unsafe or whatever. We will use the HTML structure basically just for now, because I don't see like we want to get it done now and then later refine it. Like if we can add things later on, it's easy. It's always hard to try to replicate the whole thing at once. And then you suddenly have a new system nobody understands. Okay. So for instance, they do examples like this, which doesn't really fit. Like I like this model better. So do we have anything in here? Or actually we could... What happens if I take this? So we create a doc stuff folder and we create a file in here. And we copy a file in here. So we go into the Rescript compiler, gscomp, others, belt, array, mli, dot. And then we use our make thing, we make it. It's up to date, and then we use it. And this time we will use the doc stuff, belt array mli, and we will get some stuff out there. And you can already see that even though this is like an MLI file, we pre-print it out as Rescript code. So we have a kind of doc value, with a doc string in here. Yeah, and this is like verbatim doc string code. So after we cleaned up this thing, we probably need to convert the belt docs and everything to Rescript Syntax, which will be exciting. This is something I've been waiting for 2 years now. So is there anything special in there we care about? Probably not. Shuffle in place, reverse, make uninitialized. Okay, copy fill, there's labeled arguments, split for instance. So if we take this and we throw this in an output.json, we have split. Yeah, this looks fine. Okay, there's nothing else. But unsafe. I think for this kind of stuff it's already really good. Like if you have just values and functions in there. And also externals. So external, we also explicitly parse that. We have these externals in there. I'm not sure if they differentiate. They probably differentiate between it. Psic val. Psic value. Okay, there's no pointer. There seems to be no external thing. Okay. Let's have a short break. Does this actually, does this make sense to you? Or is this like super like witchcrafty thing? Or have you been doing this already? Or have you been using this already actually? Trying to ask you some questions so you're also like challenged here. I'm not the only one scripting. Amiralis. You definitely have been working on tooling, right? You have been contributing a lot lately. Maybe let's go into some more advanced stuff like Hashmap. Yeah, Hashmap is interesting. So here this is interesting because here we have like modules in there and submodules. And we also have types in there. Okay, so here we have some edge cases. We are not getting any name for type T. I'm just staring at the screen. I have no idea what I'm doing. So we have our type declaration list. We put it into a map, get a declaration, type declaration out there, and then filter the doc attributes. Then we get filtered attributes and Oh, this is drop doc attributes. So for the printing part, we also need to drop the doc attributes, otherwise they show up in the resulting doc string. Otherwise it would be in here. Okay, so here we have a p-type variant, we have a p-type abstract. And yeah, this is like the only basic type. Case, branch, whatever. And structures. We have a doc PCD name. And I have like an OCaml doc PCD name. It's a constructor declaration. I don't care about the constructor declaration though, right now. I think this is an abstract type. This is an abstract type. P-type abstract. And oh yeah, okay, so we don't define a name here. This is a good task. So P-type abstract. An abstract type has no name, apparently. So where do I get this information from? We have a type kind. We have a type declaration with a name. With AST type LUC. Right. So we need to use our type declaration, I guess. Get the p-type name. Let's see what happens. And let's make this whole thing. Then run this. Ha! It's fantastic. I love it. The cool thing about this whole concept is that at no point, like when this whole thing, when you get an AST, it's just a matter of matching all the types. And there's no other error than type errors. It's a little bit frustrating when you're starting out, like traversing this with like 5 different folds. Okay, so we have this, and we're still missing, like I would like to be able to get modules. And we need the module language for that. So for now we have been like class language, we can completely omit that. We don't need that because in Rescript we don't have classes, I think. For the core language we already saw how this works. Like this is like the patterns and expressions and all that stuff. It's pretty simple. Extension points is also simple. But now we are entering the module language. Freaking module language. And we have signature item here. It's the same thing. So there's like different layers in the language. So you have the value space, you have the module space, and you have the type space and whatnot. Gosh, you guys are really, really silent. Are there any users in the chat? There are a few ones, but they're stalking. I'm just talking to myself then. I mean, you can also just talk about what you're doing. I mean, what language do you use? Do you use Rescript? I don't think so. Ha! Dave! What's up? You use Rescript, right? Or probably Reason right now. It's so cool when you know the people. Yeah. And you also know PPXs, so you probably also know about this kind of stuff that I'm trying to debug here. It's kind of funky. Okay, so I wanted to get the PSIG module thing. I actually need to post the link at some point. I will post the music link. I'm not sure how this works with like copyright free, royalty free, no copyright music. You need to refer to the originator. I need to do that on my stream as well, but for now this link will suffice. So what I wanted to do is so I'm matching some stuff here. So I'm matching on signature items, right? This is all I'm doing. I'm having signature items and I need to do something with them. But I'm not sure if this signature item is like... Oh wow, okay, we have been using the module language already. So the module language, every file is a module. And the contents of a module apparently contain signature items. Hi! Yusu is being late again. No, you're not late, but... you missed the awesome beginning. Like I was completely woke. I knew exactly what all these things are. And now I'm kind of struggling. Okay, so we have PSIG module, the module declaration. I think now I get it. After you look beyond these like namespacing things, like these are so distracting. I'm like, what is a PSIG? What is a PMD? What is a PMTD? What is a POpen? Like, is this French lingo there? Because OCaml is French, so everyone makes French jokes. Okay, so we pattern match on this thing, and then we can... yeah, I will probably upload this, because today I'm feeling really, really good about it. So we have a PSIG module. And there is a module declaration, and yeah, Maxime is in the house. It's obvious. PSIG is Parsetree signature. It's obvious when you know it. And it's also obvious when you know that PMD is Parsetree module declaration. And if it's like a module type declaration, it's Parsetree module type declaration. It's basically like Like in Vim, where you need to remember insert is I and delete is D. And delete invert is DIW. It's a memo technique, I think. Man, these English words. Mnemonic?
Mnemonic.
What?
Mnemonic.
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 Oh, mnemonic. Okay, mnemonic. Okay, I need to remember this. I freak out. So we have the PSIG module and the module declaration, and in there we have like a record. So this is now our record. Module declaration. Funny arrow. And I need a name. Okay, I need a name. I need to return. I need to return a sig item? A signature item? No. I'm again drop. No, I'm in the wrong function. I go back. I want to be here. So this function returns a list of doc items. And yeah, you can tell me however you how often you want. I will forget it again. Basic type. PSIG module, and then we get out the PMD attributes, and we will return egg for now, just to see if this works. Okay, yeah, it works. Okay, we have a module declaration, we have attributes in there, and attributes are a list of tuples with an LUC and a payload. And I think I've been doing this already somewhere here. I need to extract all the attributes that are ocaml.doc. Also basically this. And I'm not sure, Maxime, is this actually possible to extract into a function? Because like pval attributes, they're all attributes, right? They're all the same. It doesn't matter if they're like polymorphic or whatever. I think I can just take this and make something. Oh no, I need to copy paste that because there is like, yeah, they're generic, but I'm always wondering if you can just like use the same function for multiple generic things. But here it's actually a problem because like here we print the signature item, we drop the doc attribute signature item, and then we create a value out of that. So maybe we can abstract that into a function which gives me just the signature, because I only care about the signature and the doc string. Let's try this. I will take this. And this is something I'm not really comfortable with because like this OCaml syntax is so hard to manipulate for me. Ah, this music is really good. I should have done this way earlier. Okay, so let's say we create a extract doc extract signature and doc string, and we give it a list of attributes, and then we feed this list of attributes into our map. And now we don't have reformat, so we need to use the auto indentation. Maybe let's close this window. Yeah, I wanted to extract this code way earlier. So this would get parsetree.attribute list, and in the end it would return a tuple of string and string. And this would mean returns signature docstring. Wow, this music reminds me on an old Sega game. How is it called? Shadow of the Beast. Oh man, like I have a good friend who's like super into the 80s, 90s stuff. Also like the computer games, and like that would have been so fun to talk about. So we have the signature, and we also get the docstring. The docstring is an sprintf with this insane syntax within the sprintf. I don't know what this means. I don't care. I just take it. And we call that let docstring whatever. And then we would not return this kind of crap. Oh, this is way more complicated. So this is not a string of string. That would be an option list. But we don't know if it's a list. It should be a string list, I think. And then in here we would return the signature and the docstring. And we probably would not... We don't map. We do fold right like grown-ups. Actually, I would like to use an array. Maxime, what do you think? Does it make sense to put all this stuff in arrays already? Or should I keep continuing using lists? And if I'm using arrays, how would I do that? Would I like allocate like an array with like the length of the list? Gonna buy me some time. Because I would really, really love to not use this list reduce mechanics, but I would rather like to push stuff on an array and just be done with it, because I don't care if it's like tail recursive or whatever. Or maybe he's AFK. I think it will get me some more water, and we'll think about it 1 sec. Okay, I guess he's not here. Whatever, I just do the fold. Was it fold right or fold left? Fold left, fold right, what the fuck? I have no preference. Also, it should actually be only one item. It should be the first item and then quit. Search first item. Okay. So search first item would get attributes? But it already gets... Wait, does it use the implicit context or should it... No. Okay, now I need to go down this rabbit hole. I don't know the APIs. Parsetree viewer, okay. I have no idea about the standard lib. Oh god, no, this is not master. Oh. So it defines a loop of attributes, matches on attributes. If it's empty, then it's false. If it has location something or something else, then it's true. Otherwise, it takes... Okay. Okay, I think I got it. So we would match attributes with, if it's like empty, then it would be none. And if it's like location.text, and p string, okay, then we need to copy this stuff. This one, and then we close that. And then we are essentially doing our work here. Oh yeah, and we are forgetting this stuff here. Wow, this is... Do I need this whole thing here? This looks so disgusting. So we're pattern matching on... like, oh. I don't even know, like, I would like to have a pretty printer telling me how to format this because this looks really, really weird. Good. And then we have like this kind of stuff here. And this is fine, this is fine, this is fine. And then in here we tell get first item attributes, which would be the return value. And we also need here a default case. So if there's no element, then it's none. If there's one element with a type location txt okml.doc and a constant string, a string with a string description, string eval, then get the signature out of there. But I also need the signature item. Damn. I need the original signature item as well. Otherwise I cannot really... Whoa, what's going on? Signature item is not here. But where do I get it? It's an attribute of a signature item. I need to pass in the signature item as well. Okay. Signature item, and then it knows. It doesn't know because I need to put this after the drop something. Drop doc attributes is here. Get OCaml doc string. Oh damn, I already have this. Okay, this is already gets the doc string, but I think the other one is actually better. I'm getting there. The code is getting cleaner and cleaner by every session. Okay, p string, of course, we need to open. Excuse me. Line 233. Find first item. Find first item gets attributes. Why doesn't it like it? So it's a list. Has this Parsetree attribute list, but an expression was expected of type string Parsetree payload location LUC list. String est Parsetree. It's not compatible with string Parsetree payload location LUC. This is also like a string Parsetree p. Yeah. I think I also didn't set up my editor correctly. But I'm too lazy to figure it out. So string Parsetree payload location LUC list. What the hell is going on here? Oh, okay, this is a function, right? LUC list and return string option. Maybe it's because of the annotation. Uh, 304. Unused variable. So now we have extract signature and doc strings, which gets signature item and attributes. We take that, extracts signature and doc string, and pass in our signature item, and we pass in our PMD attributes. And we get out let item. Or actually we don't get back item, we match on that with some signature doc string and print end line signature for now, and then we return egg, and if it's none we return egg anyways. And let's see if this compiles. Of course it doesn't compile. Why should it compile? 305. So what does it say here? As a Parsetree attribute list, when expression was of type string, Parsetree layout the list. The type Parsetree attribute string is the types LOC. Payload is not compatible with String parsetree payload location LUC. This one's a string parsetree payload location LUC. Location LUC list. Attributes. An attribute list. An attribute is a string AST type.luc payload. String AST type payload. Here we have a string parsetree. Oh, wait a second. You showed me the wrong code, Maxime. How dare you? How dare you misleading me? Because there would be like an attribute. 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 Attribute string. String L. It's a list. This is like AST_LUC payload. It's a tuple. It's a tuple, and the first one is the LUC. And the LUC has a text. Oh no, you didn't. Okay, you're fine. Okay, you didn't. You didn't do it. You were nice. It's not a location, right? TXT. Oh. 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 AST types. The fuck? Is this? Are we getting closer? AST types LUC list. Type parsetree attribute string AST type LUC parsetree payload is not compatible with parsetree payload AST type LUC string parsetree. Okay, let's go back. Let's go back to extract signature items. We have PMD attributes. PMD attributes is attributes. And within attributes, we have an attribute list. And within the attribute list, we have an attribute here. And within the attribute, we have an AST types.luc. If I go to AST types, you'll see it's actually a location.luc. So location and AST types, you'll see it doesn't matter what I would take here. So if I go back, I can still do location, right? So location doesn't matter. My life is hell. Why is this so hard? Line 225. Okay. Character 6 to 126. Character 6 to 126. Yeah, cool. So this expression here, there is an error. Okay. This pattern matches values of type string, parsetree payload, right? But a pattern was expected with which matches values of type parsetree attribute equals AST types.luc and parsetree payload. I do care about the payload though. Should I? Okay, I can copy this for now. This pattern matches values of type string and a location LUC. Payload is outside of the on the right. Holy moly, no. No. Why didn't you say that before? Where's the human parsing? This is ridiculous. This wouldn't have happened with... Oh. It's a nice feeling when you solve the problem though. It's kind of like having digestion. Okay. Line 306, unused variable docstring. Sure. But I don't care. All I care about is like this. And... if I go to my foo.reezy... It's amazing. We have my modules type T, and within there we define. Oh, this is not. This is. Oh god. Okay, now I'm shitting the bed. My sub. Oh, let's call it Twitch. Oh, nice syntax again. Whew. Okay, well.doc. Get freaking lots of subscribers with this module. Good, 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 good. And now we run this on Fooreasy. Doc type, doc value. Okay, right now there's nothing, right? So we go back to our module and we should see something though. Feel like a hacker. Okay, this didn't work, but I'm not sure why. PSIC module. Just realized when I'm really thinking, I'm always looking angry like this. I I need to train my self-awareness here. I'm always looking really grumpy when I'm coding. Extract signature and doc strings. We're not even reaching this point. P-type. A PSIG module. It's a module declaration. A rec module, a mod type. 222. So why does this not work? Strict signature docs. This should actually be. There's a warning. Free one. This is not used. Why is this not used? Oh no! It has something to do with the matches. Well, that's good. Then your project owner will not disturb you while you're coding. Do I need to wrap this again? I hate this. I hate this so much. Like when this compiles now, then I hate OCaml. Prios, no way. No, this didn't do anything. No. But this changed something. This changed the flow of the program. Like, I wrap this in parentheses, and now I get like this is now actually a case which is being hit. Did I also save the full Reezy? Maybe I didn't do that. Come on. Oh, this doesn't print anything though. PSIG type? No, it should be there. So this definitely works. Okay. I don't get it. Why? Ah, this is confusing. Print end line, print. OCaml print to standard error. I have no idea why this is not printing my stuff. Because the other things do print. Like this one does print, but the other one does not. And I don't know why. Okay, now something is weird. Oh, a warning is an error. Oh my god. Oh my. Did you see what what's happening? This is saying error warning 27 unused variable. Because it has an unused variable, it's not compiling my program, so I'm like running my program over and over and over again and just wondering why there's no print end line. Freaking hell. I was missing that. Unused variable docstring. Okay, now I know what to do. I go to line 306, and this is why I made this cat picture in my tweet. Did you see that? This is exactly why I tweeted that. This. I will put this somewhere where it's been seen. I'm going all mainstream Twitch streamer kind of right now. Like this. This is it. Did I fix my error though? Woo! Compiled. Finally. Okay, so now I get this stuff here. And now I can get productive. Now, you know, like if you're collecting all your Tetris stones, you go down and make lines and lines and lines and lines, and then you'll have like the long one, the long piece, and you're like, pew, shoot down like a 6-row, and then you're getting 100,000 points, and then you die because you stack too many columns. I'm right here with this one single piece. Now I just need to put everything together. So we have drop doc attributes in here. And we provide this signature item here, signature and docstring. We print the signature. And when we print the signature, we still get the OCaml doc here. And this is because we have drop doc attributes here. And I am going to attempt doing the same thing here by taking this and get down the PMD attributes yet again. And then I have this filter doc attributes. What did I do here? List filter attributes. Okay, filtered attributes and then description, and then you create a new. Okay. PSIG module. SIG item with PSIG description, and desk is essentially what's in this thing. So we do this again. We do kind of like this as description, and we get the filtered attributes desk.psig PMD attributes. So we get filtered docs, filtered attributes, I mean, and pew, pew, pew. And then we get... Then we get a new sig item. A sig item with psig description equals psig module and crap. I need a new sig. PMD attributes. No, this doesn't help. That new desk and then I do this with PMD attributes equals filtered attributes in, and then we do this new desk. And I hope everyone knows what's going on. If this compiler will explain what's happening. Wow, this compiled on the first try. Before I was like looking for, I don't know what kind of type error because of like embrace, and now it just compiles. Okay, so what's happening here is that we are matching, like we get our signature item in there, we match on every psig module. We get the original content of this psig module, and then we filter all the doc attributes there, because as we can see in the output before, we don't want to have the OCaml doc again in the like in the signature itself, because we already got the data. We want only the string thing. This is what we have been extracting. So we need to drop these doc attributes beforehand. And this is what this does. So we filter over our PMD attributes with our predicate filter doc attributes. And this is basically matching on this thing. So if it's false, it will drop it. If it's true, it will keep it. And then we do something like in JavaScript where we would like object spread onto a new object and then create a new psig module out of that and return that sig item. So we're basically manipulating the original AST by dropping all these unnecessary doc attributes. We good? So we extract signature doc strings. We have them here. And now we will run this program again and see a wonderful, nice, hey, shoot. Okay, we don't care about this one. But we get a signature. Do you see that? Module type, module twitch equals whatever. Oh, that's interesting. What's up with that, Maxime? Are you still there? So there's this underscore, probably because probably we don't even need that. I mean, at some point, if we get a new module, we want to traverse that module again, and then we need to nest it up. So maybe. So probably this extract doc will be recursive. Signature item. Parsetree signature. Might be that this is actually a recursive function then. And then all hell will break loose. So first of all, what we will do here is we go to our doc item. We have our doc module. We have our doc module of t-list. Oh, I already accounted that in the model. We will have some arbitrarily nested structures in there. But they also should have some kind of information like so this is not enough. It should be an inline record. It should be an inline record here. Why? Because we have the items, but we also need to keep track of this particular name. This one. This one. So we define this trigger. I'm not sure if we even need a signature. It's probably just name. Because for modules, it's probably not too hard. We have a docstring. We have a docstring. And we have items. And the items are a t-list. Does this make sense? I need to... At some point I need to think about some, like... some ways to make you kind of talk. Otherwise people are just hanging out and do nothing here. You can tell me, like, if you have like a funny story of what happened at your work, like doing like coding work or whatever, let us know so other people can have a laugh too. Doc module items. So this is not items anymore. Doc module, okay, now we need to destruct that. And we have a name on the doc string. So here we, oh my god, this is so cool. We put this in here. And this is like doc string, we put this in here. And we also have name, string. Now I kind of understand why OCamlers are so like elitist about serializing everything and deserializing it, because they work with data like this. They don't even have like to think about, oh, what if my backend doesn't deliver this kind of stuff, because they have everything local on their machine. They are parsing code which exists on their machine. They have full control over the whole serialization, deserialization, whatever. Of course they want this to be pure and nice, otherwise they have errors all over the place. If I had like exceptions all over the place with this, I'm not sure if I would be happy. And it makes sense why OCaml is a good language for programming for developing programming languages, because this is like freaking awesome. As soon as you understand the syntax and whatever. But people rather write parsers in JavaScript before they write it in OCaml, because it's such a steep learning curve. I'm probably triggering a lot of people when I'm saying this. Pew! Oh, it's already 8. And it's starting to get so fun. But I will continue one thing and then I will call it a day, because Wednesday is cocktail evening and we drink them We usually drink some kind of gin tonic in some way or another. We love gin. 179 doc module items docstring name. This is fine. This is fine. This is fine. What does it say? Syntax error. Yeah, these are like this. And psic module. We're back in the game. Psic module. Psic module. And here we want to actually return an item. An item. Need to go back to my module here. Psic module. Module declaration, and in here we have a name. Gonna destructure the name. And I'm gonna destructure nothing else. We have a module type, and the module type have in the module type description, and the module type description has I don't know why I'm looking at this, I don't care actually. So the item would be doc item dot doc module, and within there we will put in name, which is pmd name dot text. Yes, nailed it. Items is an empty list for now. And docstring, and we actually didn't need the signature here. We only need the OCaml docstring. I wrote this whole thing for nothing, I guess. Although it's not for nothing, we can still use it to clean up some code. So it was a good exercise, and probably also good for you to understand how this works and how to not make the same mistakes as I did. Yes, so this extract thing is actually not needed. So what we can do here is the get OCaml docstring. But I get OCaml docstring. Oh no, never mind. I will just ignore the signature for now. We don't need the signature, we just need the docstring. And then we have our item. And then we concat our item with the accumulator. $319. What's up? This expression is typed doc item, and egg is a doc item list. So why doesn't this work? Item is a doc item T. This is oh, yes. Bam! Here we are. Doc module, kind doc module, docstring, get freaking lots of subscribers with this module. It doesn't have any items though. This is sick. I am excited. Seriously. I just realized that the doc variant has no docstring. Why? Why? Did I ever do this? Basic type. Maxime, I'm getting to a point where I want to split up my my bin. I want to have some signature files. But this is good. This is really, really good. Really, really good. We will submit that. What? Yeah, I told you grab a tea or something because this is insane. This is like this. I need some overlays at some point. This is not making it. I love this cat. Yeah, it's insane. I have no idea. And I'm sure, like, if there is one or two OCamlers in here, they are probably cringing. But I don't care, because, like, my goal is to make this work. Make it work, make it right, make it fast. Not do research for 2.5 years and then write a paper about it. Just using that thing and that's it. Good. So we're 50 minutes past my schedule. I wanted to actually do a second stream. And I'm not sure when I should do that. Because if nobody has time and nobody jumps into the stream, then it doesn't make any sense at all. I'm doing this for all the viewers. So I was thinking of doing this on a Sunday, actually. And if you're interested in this kind of stuff and you think Sunday is a good time, kind of probably a little bit earlier than usual. Usually I do it at 6 p.m, like start at 6 p.m, but on Sunday I would probably start at 4 p.m. or something. For 1 or 2 hours or something. Just to get a little bit like more streams on schedule. Oh yeah. Let's have a few questions and or let's talk a little bit before I turn off the stream. Yeah, if I would write any reason, yeah, it would probably be easier, of course, yeah. But we are sticking to the plan of having just plain OCaml 406, nothing else, no dependencies at all, not even reason as a dependency. And I'm fine with that, because this is not like... Hopefully when I'm done with this tool, it's kind of clean, like the syntax itself. If you look at the syntax, This is the Rescript Syntax here. We have like a ton of files. Maxime did a great job writing this. Like Maxime was spending a lot of time writing this for human beings. You can actually read that he's using camel case and he's using, I don't know, like comments, and he's explaining things. And when you look at the code like this, I think it's pretty clean. It's just a matter of like adapting to, like, it's not only about the syntax, right? So a syntax doesn't just mean, okay, if it's like the same AST, it will work the exact same way and it will feel the exact same way. That's not true. If you have no braces for scopes or whatever, you kind of start to write code differently. And that's why I'm like messing up everything, because I don't understand when does an expression start and when does an expression end. And therefore I'm less inclined to do like set effectual steps and in between steps, because it's kind of annoying. And in OCaml it's also like you should use currying and whatever to clean up your code. And it feels very, very different writing OCaml native and even if you're writing Reason native or whatever, it, yeah, like the platform dictates a very different like writing style. Especially when you're switching between Rescript, which is very front-endy and JavaScripty, and then you go back to this OCaml stuff, which is like pipe blast and everything, and suddenly, okay, type inference works differently now, so I need to use currying more often, and I need to create like recursive functions to pattern match on the lists, which are not very often used in Rescript. There's a lot of stuff. So generally speaking, like if we had a newer version of OCaml, we would have had a little bit better error display. Like I think the 4.10 and 4.L11 version has a very nice code frame, like in the error message. Yeah. The issue is really the lack of information about OCaml, and it's kind of disappointing because it's such a old language, and you could imagine that like in 25 years someone would step up and just write like a very, very practical, like real world OCaml is probably the closest here, and it's a great lecture, but what I would like what we would like to do here is we are very we just want to get our stuff done like in a way that we can get JavaScript developers on board and they can just write code in a way they are familiar with, and we try to not distract them too much with like functional programming and other kind of stuff. But we are also writing tools in OCaml and we want to make this platform really great, right? So we are also collaborating with the folks behind OCaml.org, right? So they are building their new website and they try to, of course, there are OCamlers who want to make this more beginner friendly. And it's just documenting such a huge language in your spare time is almost impossible. You need like to join forces and have like proper technical writers who are empathetic with like their audience and don't like to like we also need to optimize the amount of documentation we want to write. Like we try to reduce as much documentation from our documentation website as possible because people don't read. People hate to read, and it's really apparent. Like if you oh, the music stopped. So if you're like having a newcomer and he's like, oh, how do I do polymorphic variants? It's like in the language manual there's a polymorphic variants section, and he's like, oh, I didn't see that, and then people are like, or people are saying, oh, well, it doesn't interact well with JavaScript because it's not JavaScript, and it's like, this is our main selling point. Why do you say that? It's in this documentation is right there, and it's like, oh, I didn't read the docs, and it's like, nobody reads. But for those people who want to read, there's no material, or there is way too much material. It's insane. I don't know, like writing documentation is its own discipline. It's not a thing you do next next to coding, like you build a programming language and then casually write the documentation for it. It's you need like proper technical writers, otherwise it's just really hard. I actually wonder why Rescript aims to front-end first, just like Elm. I mean, nobody say that officially, but that is the truth. What do you mean, Yusu? Do you mean like... Do we never communicate that Rescript is a front-end language, or... Because I'm pretty certain we do. Elm does a really great job in documenting though, because they, Elm does a really fantastic job because they don't want to overwhelm their users with too many concepts. They really boiled it down to the Elm architecture, and there's also this beginner program API, and they explain it by, okay, you want to get some data, you use like effects, and even though it's like such an unfamiliar concept, like the whole Elm architecture, functional programming thing, people get it. You don't need to be like, even I know a lot of people who got into Elm who are not functional programmers at all. In fact, they are not even like proficient programmers, but they can still write Elm because they just feel there is less noise in the syntax, is very clean, the APIs are well communicated. Everything is kind of like unified. There is no, rough edges on the documentation. Everything is kind of, it's like a monolith, a beautiful monolith. Oh, right. Yeah, people care about backend actually, but we have a few users like Murphy who is... there are some users who are using Node, and what we try to communicate is that you don't really need, like, if you understand like this whole external concepts. I mean, of course you need to write a lot of externals to get productive and everything, but we try to really shape the language in a way that it's almost identical to JavaScript, so that people don't need proper like frameworks to be able to use Fastify or Express or whatever. I don't know. But for the front end part, it's just like, this is like our thing, right? So it's always easier to provide support for something when you use the technology for a certain topic, and we use it for front end a lot. And front end, I just feel like it's a very good use case. Yeah, you can divide docs into sections, that's right. But this is also, we try to, okay, maybe let's go into the Rescript docs, for instance. We try to put it into sections, right? So we have our language features and everything. And back then, the JavaScript interop was on the Parsetree homepage when Rescript was called Parsetree, and the Rescript React or the Reason React docs were also on another website, which still exists. And this kind of decentralized way of ordering information is kind of troublesome, because you need to document it somewhere how to find it. And even now that everything is like in one place and even is like separated in different sections, people just don't find it. I also think that a lot of people just don't know that the package index exists. And you really need to understand where does the user come from and what does he try to achieve and what docs will he most likely look at in the first place, and then try to guide them through to the right section so they can just get productive enough so they don't really need to read the whole thing. Yeah. And we are like, for instance, I'm trying to find a specific language construct for OCaml. And I'm like, okay, first of all, I don't know, I have some random code snippet. Let's see. Maybe I have the match keyword, and I'm like, oh, what is the match keyword? Or what is with? Or what is let? What does this do? And my ideal vision is that we don't even need like this overview here, right? Like, because this is again some kind of semantic mapping. You need to know how something looks like. Like, you need to know that the braces are a record, for instance, and then you're like, ah, this is a record. Or if it's a tuple, oftentimes people don't know what a tuple is, because in JavaScript there are no tuples, there are arrays, right? And for me, my ideal use case would be, you go to the docs, you go to the syntax lookup, and you're like, okay, what does this arrow thing do? And then this is the pipe operator. Okay, now we can talk. We need to establish, like, you have a newcomer who has never used your language before, and they have no idea how to call it, and there is no way how to define it, right? Unless you're reading the spec and you know exactly, oh, this is a PSIC value. You're talking about a PSIC value. And here we are giving it names, like human names, like there's a floating point multiplication operator, or this is the concatenation operator, or this is the getIndex decorator. This is a decorator, you know? And establishing a simple language without even I didn't even do anything. This is completely interactive. I'm like, okay, I just want to discover the language. Oh, this is the if else. Oh, okay. I will just take this, copy paste this, maybe have a playground there. And I didn't even install the tools, you know? I didn't completely copy the whole thing. I never installed the tools, and I don't need to, because all things I need are already there. And the most important thing is also have a proper design. Think about hierarchy. Where does the user look? Where does the user look, like in the very beginning? How do you communicate hierarchy? How do you, like, we don't do like communicate the hierarchy really well here, because like we are now in the language manual and we have some kind of breadcrumbs, but where are we? How do I get back to this grand overview? We always think in like tree structures or whatever. And then when you get to a section, it's like, oh, boom. Okay, I know exactly, this is the syntax lookup. There's like, okay, let's try something out. We have the underscore. Okay, what does the underscore do? This is a placeholder. Okay, and I'm already settled. And I also have references to the right parts. So now I don't even have to like figure out on what page is like the information I need. Okay, I'm getting into this ranting mode because I'm so upset about how careless some documentation is being structured. And things like this are the most annoying thing. Like, people use API docs as their main means of communication. And I've never thought this is good. Like, also when I was doing a lot of Javadoc is great if you have to look up some like APIs, but it's not a main mean of communication. This is not how humans communicate. It's almost upsetting that they just generate some docs out. Most of the time they are not even up to date or incomplete, and sometimes they're just type annotations. It's like, okay, what should I do now? there's no tutorials, there's no examples, there's nothing, and this is something the JavaScript community actually do. And I can imagine that this is because they don't have types to begin with, so they need to have proper examples and tests to demonstrate how to use the API. And this helps forcing them to make examples, otherwise nobody will use their code. Yeah. Sorry, I was getting a little bit upset here. Rescript docs became one of the most cleanest docs. That's great. Like, if you think so, this is great, but we are not nearly done. It's almost like a library doc site, and it makes it feel less scary, I believe, but also a bit shallow than it should be sometimes. Yeah, yeah, we really try to simplify. Our goal is to shave off every fat part that's possible. If we can remove it, we will remove it. Yeah. Yeah, Rust docs are okay. I never used Rust properly, so I cannot really tell how the daily use experience is. There's some things... Yeah, the Rust... There's a lot of noise when you go to the website. There's a lot of stuff going on. Okay, we learn. We have a book, we have a course. But I guess what you're referring to is the book, right? I think if OCaml would organize their docs like this, it would also be easier to navigate. Just as a comparison how the OCaml manual looks like. It's like this. I mean, it's a great overview. Like, now I get it. Now I get it. Now that I'm working on like compiler internal things, I get this manual much better. I understand what they're going for. And I understand that they want to keep it simple. And they also probably don't want to reinvent the whole docs every few years again. So it makes sense. But yeah, like, this navigation is completely insane. This is one of the reasons why I think it will never be good to learn by JavaScript developers, because they're not used to that. And it looks like it's from the 90s. And it doesn't imply to be a modern language if it doesn't have a nice website and nice like structure and nice, I don't know. But other than that, like, the content is actually really good. Like, one of my favorite things, which I had to read like 5 or 6 times until I understood the topic, was polymorphism and its limitations. How like weakly polymorphic types work, and how is it called? So we have weak references, and then we have like this contravariant thing and covariant thing. So the plus sub thingy right there, plus a, which means that's basically immutable, and or establishes some kind of constraint that this, like the values inside this type will not change. I wish they explained it a little bit easier, but this is like, I think, how language developers talk about this topic. And I think Rust is probably more concerned about their users, like who is going to use this and put themselves in the shoes of the users. If I have never done some coding before, how would I write this documentation? And they also use, hopefully, examples that are not only foobar bass, but more a little bit more realistic, so that you can at least yeah, I don't like this y xy thing if there's no if there's no meaningful example so that people can relate to it. Okay, what is that? Oh yeah. Yeah, I don't know. Like, this has something to do with the language itself, because they need that kind of stuff, because they have like traits, and traits inherits stuff, and you need to be able to navigate this quickly. So we have borrow T, and then... But there's still a lot of things going on. A lot of stuff. Oh my god. But I guess like it represents the whole ecosystem really well. I'm pretty interested how we will tackle the API docs. So the thing I've been extracting here should be used for this section, like for the API section that we have now. Like this, I'm not happy with this hierarchy either. Like, I don't like the way how we documented this. It's not good, but I had no chance on doing it differently. So as soon as we can as soon as we are able to generate this documentation from like JSON or Markdown, whatever, we have an easier time like making this like this. Where is it? Like this. We can make it a little bit more interactive, but this will take some time. Yeah, searching is super fast. I wonder how to do that. Is it only the core modules? Like the ones that are shipped with Rust itself? It looks like it. But there's also cargo, I guess. All crates? Alloc core, yeah. The polymorphic stuff you were looking at is available in Rescript? Yeah. The polymorphic stuff is just an explanation of how type inference works. Like this one. Like it's not a language mechanic in a way, it's just a type system. It's just an explanation. Like we have the plus thing, yeah. And we can also, I think there's like this, yeah, like this one. Explicit polymorphic annotations, we also have that, as far as I know. But it's something like we don't expose this information because it's most of the time more a distraction. That's why we don't document this kind of stuff. We will document it, but it's a little bit lower on the priority list. Now I understand why you're called Crateless. Is it because you're a Rust, like a Rust enthusiast, or? Okay, yeah, this is like an explicit website. I should probably check out how they implemented this, because I'm still looking for an indexing version for our packages, like an indexing server kind of thing. Oh, by the way. Oh, wow. Okay. One sec. One sec. One sec. I need to check something out. need to check something out. Where is it? Where is it? I want to show you a sneak peek of how we want to, like this. This is how we want the package index to look like. This is like a design from our designer. And this is going to be really cool. Like you search for something and you have like proper hierarchy. And it's beautiful. There's user guidance, like people should look for the official resources before they look for the community resources. And it's beautiful. And also like the related sections. Let's say, okay, just imagine you're like the first time user, you want to consume a package, but you also want to publish a package. You go to the related section, you're like, oh cool, publish Rescript packages is here. I click on that and you get to the right description. And then we establish hierarchy by still keeping like the most important related topics on the right hand side. So we can click back and we're back to this page. And this is what I meant with like, think about how the user will interact with this whole thing and really put all the tools in his hands to with the least clicks as possible. So they don't have to look around in the language manual, they don't have to find some arbitrary docs in the Rescript React like section or whatever. Everything should just be like right where it is, accessible. And also like responsive, right? Like if you're, we had a lot of users back then on Discord. Now we don't use Discord anymore, but like people who are on the mobile phones should also be able to access the data, right? And a lot of like platforms just ignore that fact. And we are in a time where mobile is just like everywhere. And yeah, this is going to be really nice, like when we do that. And now imagine, this is just like one part, this is like the package index. Previously we also had like the playground redesigned, but now imagine like this kind of design for the language manual, for the API docs, for the blog. I mean, the blog looks already really nice, but it can be nicer. And really like, we're getting there. The only thing we are still needing is more information from how do the user interact, what is the biggest struggles they have, what kind of information is the most important to them. And then we optimize, really like optimize their clicks, optimize their like user story, where they're coming from, and the user funnel. Like if they are Node developers, we put them into Node related resources and they figure out their way. Like every user has a unique way of interacting with this, but we try to collect all the data to see how to put them on the right tracks. Anyways, it's almost 1 hour over. I think I will close the stream now. And it was really great talking to you guys and gals. As I said, maybe I will do a Sunday stream. Would be nice if you hang out in this stream as well, if you have time or if you feel this is like interesting. And yeah, have a great evening or a great morning, and see you next time on next week, Wednesday or Sunday. Bye bye.